Okay, so we are discussing the liquid penetrant test. So here, this liquid penetrant test, it is also known as the dye penetrant test, and dye is nothing but a sort of coloring agent. So here we are using a dye. That's why this penetrant test is also known as the dye penetrant test. It is a low-cost, non-destructive method used to locate surface defect in all porous material. Porous material means to say that those type of material which can allow the liquid metal to flow inside. So it is very low cost. Why? Because we are using only a sort of liquid penetrants which is very economical to use. This test is widely used to detect surface defect in casting, welding, and forming. So this type of testing, this is liquid penetrant test. We can use this test in order to monitor various sorts of surface defects in casting, welding, and forming process. The defects such as hairline cracks, if there is a crack on the surface of the product, surface porosity, if there is a porosity, because in casting you have seen that there are various types of porosity that can occur on the surface of the product. So that surface porosity, fatigue crack, if there any crack that exists on the surface due to fatigue, are rarely detected using this LP test. This is also known as the LP test. LP test means liquid penetrance test. So let us look at the procedure of how this liquid penetrant test works. So suppose this is the workpiece, or this is the component that you are having, and there is a crack inside this. There is a surface crack there inside the on the surface of this particular specimen. So you might be knowing that if you are having this specimen exposed to the atmosphere, then there is a chance that this all these cracks will get filled with the dirt. So the second step is the cleaning. So you are supposed to clean this dirt from the surface and from the crack. So you are supposed to clean this specimen very properly. So first we are having this specimen with crack inside. Since it is filled with the dirt and dust, so you are in the second step, you are supposed to first clean this specimen. So see here, here we are having some dirt inside this crack also, on the surface also. So we cleaned using this some sort of water and all, water and cloths. So we removed this dirt. So after removing this dirt, what you do? Application of penetrant. So here we are applying the penetrant. Okay, so here you are using red color dye, that is uniformly spread the red color dye on this surface of the workpiece. Now, removal of excess penetrants. So once you are going to pour the dye, or you are going to apply the dye on the surface, what will happen? If there is any crack, so that dye is going to fill into that crack also. So in the next step, you are going to remove that crack. So here in this step, we have removed excess dye which is over here using some cloth and all, but this is still remain there. In the next step, what you are going to do? We are going to application of developer. Developer is nothing but some sort of agent which when apply on this surface, then it will going to suck this liquid dye and it will get colored. Suppose here you are going to apply the chalk powder. On the surface of this, you are going to apply the chalk powder here. What will happen? This chalk is going to absorb this color. This is going to absorb this color, and what will happen? This chalk is red at this portion where the crack appears. So developer is some sort of like that material only. Okay. So application of developer, that will let us know that where the crack is. So here, suppose you apply the chalk here. So what will happen? That chalk over here is going to absorb this penetrant material, and it will show the defect is here. So finally, we will inspect the where the crack actually is. Okay, let's see if this video runs or not. Okay, let me check. this is not working. Just wait for a minute. Okay. So can you see this screen? Yes, hello. Yes, Kiran.
Yes, sir.
Can you see this
Yes,
screen?
sir.
Okay. So this is the
Yes, sir.
how this dye penetrant test works. So here you can see that dye penetrant test. So here we are having a coating on this test piece. And suppose we are having a crack over here. This is the test piece and we are having a crack over here. So first is the pre-clean the test piece so that we can remove this coating of the mud or any other dust. So you see this is clean. Now this crack appears to the surface. Next, apply penetrant. So here we are having this penetrant or you can say dye which we are going to apply on the surface of this specimen. You see here we applied this dye and this dye will going to fill this crack also. And you are supposed to give it some time so that the penetrant is going to fill the crack. Next, you just rinse it with water so that excess dye that is there on the surface it is get removed. You can see it is remained here and other dye has been removed from the surface. Now you are supposed to apply the developer. Okay, here this is the developer. We just apply the developer over here like this and wait. Why you are waiting? Because this developer will soak this and this will color will going to appear over here. Now look, in practice, how do we do? We have explained the principle. Now you see how actually we are going to perform the test. Suppose this is the specimen that we want to test. This is the specimen. So first apply the dye. You see completely the dye has been applied and 10 minutes of dwell time. What is dwell time? It is the time for which we are allowing the soaking of this dye into the crack. So then we will clean it with water. You are supposed to wash it very clearly so that it is not going to remove the dye that is filled in the crack. Okay, otherwise we will not be able to detect the crack. After cleaning with water, what we are going to? We will going to dry it up using this cloth. Next, we are going to apply the developer. So this is the developer. Now it will dry and it will let you know that where the crack is there. Now you can see here all this here the crack is there inside on the surface of this particular specimen. So you see all this red color shows that there are the cracks. Here the cracks is there, here the crack is there, here the crack is there. So this way you can predict the surface crack using this liquid penetrant test. Let me show here you also. This is another component. The same way, 10 apply it, then 10 minutes of dwell time, clean it, then dry it up. Then we are going to apply the developer. Now you can see where the crack is. Here the crack is because the red colors appears here, and so this way you can detect the cracks using this dye penetrant test. Okay. So today we have all discussed this visual inspection test and this magnetic particle testing and this liquid penetrant test, and the last one that I am going to explain you is the ultrasonic test. Okay, so this is the last type of testing that is going to I'm going to explain today. So that is the ultrasonic test. So ultrasonic means, what is sonic? That is sound. Ultra means greater than sound. The sound waves having frequency greater than this sound waves. This is known as the ultrasonic frequency. Okay, so you see here, this is the spectrum of sound. It is given over here. So here 20 hertz to 20 kilohertz. Between this is known as the acoustic emission. Means this sound we can hear. Below this, infrasound. If the frequency of this sound wave is less than 20 hertz, so that is known as the infrasound. If the frequency of the sound wave is greater than 20 kilohertz, then it is known as the ultrasound. So this frequency we are going to use in this particular test. So ultrasonic testing is a non-destructive test in which ultrasonic waves. What is ultrasonic waves? The waves which is having frequency higher than the 20 kilohertz is used to detect the location and size of the defect. In all the types of testing that we have discussed so far, whether it is visual inspection or is it this magnetic particle inspection or it is this liquid penetrant test, we are only able to detect those defects which are open to the atmosphere. Okay, so means which defect that is open to the atmosphere we are able to detect using the techniques that we have studied so far. But what about those defects which are there inside the material, which are present there inside the material? So for that, in order to detect that type of flaws or that type of crack, we can use this ultrasonic test. So using this type of testing, ultrasonic test, you can detect the location where this crack is there inside the material, and also the size of defect. Means what is the size of that particular crack or defect. Both you can predict using this ultrasonic test. So ultrasonic waves are the high frequency sound waves which vibrate at a frequency higher than the audible limit of human hearing. Means waves which are having sound waves which are having frequency greater than the 20 kilohertz is known as the ultrasonic waves. So in this ultrasonic test, we are supposed to use that particular sound waves. That is known as the ultrasound. Okay, let's see what is the principle of ultrasonic wave. Properties of ultrasonic waves. So ultrasonic waves are very similar to the normal sound in terms of physical properties. Only our human ear cannot hear that. Means all other properties of this ultrasound is same as that of the normal sound. The only thing is our human ear cannot hear that particular sound because it is above the 20 kilohertz. In your class 12 physics, you might have studied this. Our audible limit is from 20 hertz to 20 kilohertz only, and since we are using this ultrasonic waves, So this is having frequency higher than the 20 kilohertz. So our normal human ear cannot hear that waves. So in addition to that, it has following properties. Ultrasonic wave cannot travel through vacuum. It cannot travel through vacuum. It requires some sort of medium. They travel with the speed of sounds in a medium. So speed is as the normal sound. They do reflection and refraction as like light waves. Similar to the light waves, these sound waves also shows reflection and refraction nature. Velocity of these waves in a given medium depend upon density and Young's modulus of that medium. So what will be the speed of this ultrasonic sound waves in a particular medium? That will depend upon the density of that particular medium and Young's modulus of that particular medium. So here you can see that speed of ultrasonic wave is more in denser mediums. And what is the denser medium? Solid is the most denser medium. So the velocity of ultrasonic wave is highest in this solid, followed by liquid and then in gas. So you can see that in steel, which is solid, the velocity of ultrasonic wave is this much, 5920 meter per second. In water, that is liquid, its speed is 1480, and in air, its velocity is 330 meter per second. So we are having this density of the solid very high, and this speed of ultrasonic wave is more in denser medium, and this solid is very much dense. So we are having a very high velocity of this ultrasonic waves in steel because of this denseness of this particular steel medium. Okay. Okay. Now let me show you how this procedure of detecting cracks via this ultrasonic test. So first is high voltage electric pulse is produced using pulsar. So suppose this is the test piece. This is the test piece, and here is the crack. Here is the crack. So what we do first, we are supposed to put transducer onto the surface of this workpiece, and then high voltage electric pulse is produced using pulsar. So using this pulsar, we are going to produce high voltage electric pulse. With the help of pulsar, this transducer with the help of this pulsar generates high frequency ultrasonic waves. So what is the function of this transducer? This transducer is going to produce very high frequency ultrasonic waves. That ultrasonic waves is going to pass through this sample. Now you can see these ultrasonic waves is forced to pass through the test sample. Now we are going to pass through these ultrasonic waves through this sample. Now you just notice one thing. Suppose ultrasonic wave is coming, because if this is the diameter of this transducer, it is going to generate ultrasonic waves everywhere. So here the ultrasonic waves come like this, and it will strike over here and it will reflect back. But here it will going to come from here, and since it meets the crack over here, so it will reflect from here. Okay, so these waves is traveling larger distance, but this wave is traveling shorter distance. So that is the very basic principle. We note the time of getting back the signal. Suppose here, if you are going to receive this signal, what will happen? This signal you are going to receive in very less time, because this distance traveled is very small. But here it has to travel this much distance. So in order to receive back this signal, you are supposed to involve larger time. So here you can see this two echo, one echo is here, other echo is here. So you can see that this echo is taking less time. This axis shows the time. So you can see here, this is coming at this time. It means it is the crack is present here. And this is the back surface echo, which is going to strike the other end and it will come back. So here you can see the ultrasonic waves when meets discontinuity. When it meets discontinuity in their path, the part of the energy will be reflected back. So the part of the energy means, because ultrasonic waves is coming all around from here, so some of the ultrasonic waves come and strike over here and it will be reflected back. So the reflected wave signal is converted into electrical signal. Here you see we are converting this reflected wave signal. This is the reflected back signal. This is converted into this electrical signal by a transducer and is displayed on the screen. So this is the screen oscilloscope. Here you can see the reflected signal. So by using this principle, you can also detect the location and the size of the crack. Greater the size of the crack, it means greater will be the intensity of this signal. Okay, so by seeing the intensity of signal, you can tell the what is the size of the crack, and by seeing the time of the reflection, you can tell the where this actually the crack is location. Okay, so let's see whether this is working or not. No, but let me show you that there only. Let me show you the how this ultrasonic test will be done. Are you able to see this screen? Hello?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Examination. So let's see how this ultrasonic principle work. So this is the workpiece we are having with us, which is to be tested. So here this is used to generate the ultrasonic waves. Like this, the transducer generates ultrasonic waves inside the sample. It generates as well as it receives the signal back when it strikes the rigid support. Now see, this is the workpiece and this is the ultrasonic waves, and it will strike over the this end and it will back and it will detected by this transducer and it will be converted into the electrical signal. Now see, this is the workpiece we are having, and this is the transducer that is used to generate the this ultrasonic wave inside this test sample, and it also is able to capture the signal back. Once it will strike and it will reflect it back, it is also captured those signals. And suppose this is the cavity that is present inside the sample, means this is the defect that we have to detect. Let's see how this works. Now see, this this waves is going to travel like this and it will strike over here and it will travel back and it will receive it. Now you see here what will happen. This part of the ultrasonic wave is going to strike this cavity and it will going to be received by this transducer. Here most of the ultrasonic waves is going to be reflected back. So the waves, time taken by the waves from traveling from this place to this place and then again reflecting from this place to this place will be longer, and from this place to this place and then back from this place to this place will take a smaller time. So by analyzing that time of this getting this reflected signal back, we can predict the location. Now you see. with transmitter. This is the transmitter and receiver. This is the defect, and this is the monitor. This will represent the intensity, and this will represent the time. Now you see very high density, intensity, transmission, and this is bag. So this is the transmitted intensity, and this is the reflected intensity. Here you can see this is the echo, because some part of this ultrasonic wave is strike and will be detected by back by this transmitter. So this is the defect. Now you just see how ultrasonic test actually works in the real practice. So this is the transducer, and this is the our test specimen, and this is the screen. This is the intensity, and this is the time period. Intensity, and this is the time. We are going to apply the ultrasonic wave through this transducer. Some gel is applied so that this waves is not going to interact with the air. Now see here. Now this represents the echo that is generating from the defect. See here. So this is the defect. By measuring the time period of this time after which this echo comes, we will able to predict the location of this particular defect. So here one defect is there, other defect is present here. So by measuring this time period and by knowing the velocity of this ultrasonic waves, we can predict the location of this particular. Now you can see here, the moment it is going to strike this cavity, this is the defect. Okay. You see here, the echo is coming here. The moment it is going to pass this defect, it will get removed. See here, removed. This is. Now again, it will going to strike here. Again, this echo will come. Now, one thing you can note that this defect is located at a smaller distance, so this time will be reduced. But in case here, the time will be somewhat around here. So by measuring the time interval after which we are going to get the reflected signal, we can predict the location of that particular defect. So in this way, we can find this defect using this ultrasonic test. Okay, so this is the end of the session for today. Okay, so I hope all of you have understand about this non-destructive testing. Is it? Okay. Is it clear? Yes, sir. Any question?
Yes, sir. No, sir.
Okay. Okay, then we will meet in the next class. Okay. So you do you know about the lab exam when it is?
18, 19, 20th, sir.
Yes. What about this materials science and metallographic, metallurgy and material testing lab? When it is? On 20th, I think.
Sir.
20th, yes.
20.
Whatever I have taught to you, just prepare it. Okay.
Sir, for how much marks, sir? For how much marks, sir?
It will be of I think 40 marks. I will tell you. Okay. I will tell you after talking to the IC. I will let you know. Okay.
Yes, thank you, sir.
Okay, thank you. Okay, stay home, stay safe. See you soon.
Sir, attendance like
Attendance, just mention in this chat box. Okay, I'm just giving you 5 minutes. You just mention in the chat box. Do it quickly. Okay, done. All of you are done.
yes, sir.
Okay then.
Yes, sir. All of us done.
Okay. Okay then. See you next time. Okay. Bye bye.
Yes, sir.